I know you should never go full retard, but how about full cringe? Do you want to be a black belt in Alibre? Well, you need to know these black belt moves. Okay, so let's suppose we've got this block and we want to chamfer these edges, right? And let's make them 5 millimeters. So I type in 5 millimeters and then I select this window. So I get 1, 2, 3. Where's the fourth? I need to spin the model around. Or do I? Look at this. There's the fourth. Hit apply. And it's done. Okay, so how did I do that? Well, that's easy. If you go into the view, you can switch between shaded and visible edges and the shaded and all edges. And these commands are actually hotkeyable, right? So what I've done is I've hotkeyed them and I can switch between them. And in Alibre, what you see is what you get. Well, what you see is what you can get. So if you can see it, a line or an edge, you can click on it and select it and do whatever you want with it. So if you turn shaded and all edges on, you can actually select hidden edges for commands, right? For example, I just filleted these back edges. It's as easy as that. Now there's another hidden little gem in Alibre, and it's within the midpoint constraint, right? Of course, we all know what the midpoint constraint is. You click a point and you click a line and that point becomes the midpoint of that line. Well, there's another way to use that constraint. Okay, so let's restart it. And that's by using it with 3 points. So if you do that, what happens? Well, the first 2 points define a linear segment. And then the third point you click is made so that it is always on the perpendicular bisector to that linear segment that the first 2 points define. Okay, that's all well and good in theory, but what does that really do? Well, let's suppose that we want these 2 circles to be symmetric around this point and in the middle of the part. How would I do that? Well, I've already projected this in because I used it in a constraint and Libre projects it in automatically. Let's see what I'm going to do now. I want to make these 2 circles symmetric, right? So first I'll start with a horizontal constraint rather, and I'll make them horizontal. Okay, that'll show the function of the midpoint constraint better. Then I'll start my midpoint constraint, which I have hotkeyed. Link here to my hotkey video. So I'll start my midpoint constraint and I'll say that these 2 lines will define my linear segment. And then this one, this origin point, is always going to be on the perpendicular bisector to that linear segment. So if I click here, look at what happened. These 2 are now symmetric, okay? And if I drag to the left and select them and then hit on a constraint, it applies to both of them. I'm almost there, right? But I want them to be on the same line, right? On the same plane as the origin. So how do I do that? Well, I define this linear segment, okay? And then I click on either one because they're constrained to be horizontal. So there you go. Look at what happened. Now that's the only way you can move them, right? And if I give them a couple of dimensions, like so, these are now fully defined. The advantage to doing it this way is you've got a significantly cleaner sketch, right? You don't have any excess reference geometry clogging the screen up, and in complex sketches, this can be a win. Okay, now let's do this. Let's project everything in, and I wanna make a cut here. Let's make all of these vertical. Okay, and I want to make a cut like so. Make this horizontal as well. Give this a value of 2. That should be enough. Now look, the way I made this, right? The only dimension missing for me to fully define this is this arc. Okay, but what if I wanted to give a diameter value here? So I click here. Okay, now wherever I move this, I'm only getting a radius dimension. But if I hold shift, then move my mouse ever so slightly, first of all, the text box becomes a little larger, and secondly, the leader now denotes a diameter. If I click, I get a diameter value. Okay, so now I can perform this cut and I have defined a diameter. Continuing on, there are a couple of interesting tricks in Alibre when it comes to dimensioning apart from that diameter value. And one is auto dimensioning. Okay, so I project everything in. I'm going to create a center rectangle around the center of this circle here, of this hole. And I'm not going to click yet. Look what I'm getting. I'm getting text boxes that update with the lengths of the sides of that rectangle, right? And the first one looks like it's highlighted blue. So look what happens if I type in a value, right? We can type in values there. So if I hit tab, that one turns green. And then let me type in a value on the other one. Now I can either hit tab or enter, and look what I got. It is creating the dimensions automatically. Because the center rectangle in V27 at least, you need to add a constraint to constrain the angle of the rectangle. But look what I got, right? I got the dimensions put in automatically, and these are actual dimensions. They're not locked or anything. I can change this to make it whatever I want. Okay, so okay, that's cool. But what about a line, right? Of course, that has a single dimension, the length, or does it? No, it doesn't. It's got two dimensions. As you can clearly see on screen, as I move the mouse before I click, I get two things that change. One is the length, the other one is the angle, right? So if I type in 50, tab, I get taken over to the angle text box. And if I type in 30 and hit enter, I will also get an angle dimension. Okay, so some pretty powerful stuff if you want to do some rapid fire dimensioning there. And of course, I can convert this into a reference figure, and I've actually hotkeyed that. So let's do it. Rectangle here and a reference angle up here. And let's do another cut extrude. So the next thing I want to talk about is how can you create reference axes based on sketch entity. Okay, so here's how you can do that. Let's say that we want to create a reference axis that follows this sketch reference line. Well, if I come out of the sketch, I open my axis command, you can see the little outline of this cutout. And if I click on it, it'll actually pick up the edge, but I don't get that dotted reference line. How do I create an axis based on that dotted reference line? Well, what I do is I need to go from within the sketch and create that reference axis. And I can do it through this command in the references tab. I hit this command, it says insert axis. I select the line and I am told that I selected reference line number 12 and the method of creation is sketch line. And I can even have it offset, right? Positives will be over it, negatives will be below it. And I'll just hit apply. Looks like nothing happened, but as soon as I come out of the sketch, there's my reference line, right? And you can see that it is on the sketch plane as well, right? It is created on the sketch plane. But imagine that I also wanted another axis, right, on this point, going inside the sketch plane, right? Like being normal to the sketch plane. So how do I do that? Well, I open the same command and I just select a point this time. And as soon as I select a point, the method of creation changes. Notice I don't get the offset option anymore. The method of creation changes and it says that now it's sketch point and plane normal. So if I hit apply and exit my sketch now, look what I got, right? I got the second axis normal to the sketch plane at that point. So that's a way to create reference geometry pretty quick and pretty fast. And of course, this is fully parametric. So if I change anything here, like make this 5 degrees and make this 20 millimeters. So I completely change where this point is. Now I also changed where this axis is, okay, and this reference axis as well. So these are completely parametric and follow the sketch entities. Okay, so let's say now that I just turned off my axis using Alt2. Let's say now that we have this situation, right? I want to project this in, and I want to make an arc like so. I just click to create the endpoint, and let's say that I need a radius of 500 millimeters. Okay. Now you can clearly see that I can't see the center anymore, the point of the center, right? It's all the way down there. So let's imagine that I want this arc to finish right over this point. Okay, sure. And actually I'll create this, I'll turn this back into a geometry. I'll make another line here because I want to create an extrusion there. Okay, and what I want is for this 500 millimeter arc to end there, so that the tangent line to that arc is perpendicular to this line, right? So that where this arc ends, if I keep going in a straight line, I'll be perpendicular to this. Now, the way you would do that is you would just take the center and you would make it coincident to this line. Okay, but look, the center is down there. Imagine that this is in an assembly and there's like 100 things going. So how do you do that? Well, Alibre actually understands that as a perpendicular to a circle, right? A line can be perpendicular to a circle. So if I do that, well, what it does then is exactly that, right? So if I create a line then that this is tangent and I measure this distance, this angle, I'm going to get 90 degrees, right? So that's what it means in Alibre for a line to be perpendicular to a circle. So let's extrude that all the way to the back here. Okay, now let's say that I want to create a line here. Right, I want the line to go from here to here, and I want this, of course, to be vertical. So what I want to do now, right, is create a revolved cut. Okay, this could be a half pipe of some description or use, right? So I want to do this, and okay, so this, let's say that's going to be a radius of 10, this is going to be a radius of 6, and this is going to be a radius of 12. Okay, so I'll make these two equal and 20 millimeters, and then I'll just make the whole thing 62.5. So now I want to do a revolve cut and create this half pipe. However, I don't have an axis to revolve it around. So what would I do? Well, certainly I can use this method and create an axis like this, and then use it to revolve, which is actually how I showed it in an earlier video. But there's an even easier way, which I didn't know back then, which is this. You see how this sketch is highlighted blue? That's because it is selected, right? If I deselect it, it becomes red. Now, that is because I'm showing my sketches. So if I go into the View tab, this little toggle is selected, right? It shows you the sketches I've created while making this part. Now, let's turn the sketches off. I go into my model tab, revolve cut, I select this sketch. You see it highlighted, but there's no way for me to select that line there as the axis, right? Now, Control-Shift-K turns my sketches back on. And remember what I said earlier, in Alibre, what you see is what you can get. Check this out. You select the sketch, we hover over this line, and something happens. So let's click on it. Now the axis is the sketch line. Okay, how cool is that? We can actually perform the cut now. And yeah, well, okay, the way I designed it wasn't very clever because it's not cutting. Okay, but you see what happened there, right? Because I was showing my sketches, I was able to click on that line and tell it to be the axis of revolution. So in Alibre, it pays to have your sketches showing. And with that, right, let's go make a new part, because I will now show you how we can create layout geometry in Alibre. So how do we get layout sketches in Alibre? Okay, let's start at the XY plane. I'll start with a center rectangle, 100 by 60 again. That should be fine. Let's give it a horizontal to fully define it. So I want a block like that, okay? And then what do I want then? Well, I need another, on the top surface, I will extrude this thing. Well, you know what? Yeah, let's give it another horizontal here. Okay, well, I didn't auto-dimension it, right? So let's say 12 by 80, that's fine. And let's go make fillets. And on the edge here, right, I'll have a little post that has a distance to that edge. So it's concentric with that fillet, and it has a distance of 0.5 millimeter. And that post is going to be a third level up, okay? So how do I use this layout sketch now, which I drew? How do I use it without redrawing it every time? Well, I come out of the sketch, okay? Click on my XY and start a new one. Okay, I have my sketches showing. So if I open the projection menu, and you can only do this through the projection menu, not through the quick project, look what I can do. I can project specific lines. I can maintain association to source. And then I will extrude this for 20 millimeters. Okay, now I want to go up here. So I'm sketching on this top surface, but where's my sketch? Where's your sketch? Right, it's still there. It's still underneath the part. Okay, so I select everything here. Maintain association. Extrude for 5 millimeters. Okay, and now finally, let's go here. Open the projection menu. I want to project this in, maintain association, and extrude that for 50. And this is a layout sketch in action. And just to show you that, oh, by the way, it helps if you name the first one layout, right? I mean, it helps me, so I do that. If I go into this sketch, right, and change something, let's say that I change this to 210, I change this to 45, and I'll change that 12. I put there initially 220. Deactivate the sketch, generate to last feature. It is a layout sketch, right? It's following the initial layout. So that's how you would do a layout sketch in Alibre if you needed to. Some people swear by layout sketches. I find them redundant in 3D parametric CAD, but you know. Now, another thing I want to show you, really cool thing, is the context menu, right? Alibre's context menu, or as I call it, the Harold bar. I call it the Harold bar because Harold L, whose YouTube channel you can find, he's got a YouTube channel and some amazing insights in Alibre. He's the one that basically told me how to use it efficiently. Okay, so when you're in Sketch, Alibre can open an in context bar with any commands that make sense. There are two ways to do it. You can either click on blank space, right? You see it popped up as soon as I move my mouse, it fades out. Or what Harold told me, which is a lot more useful, you can just hit your space bar, right? So right now I can either select a sketch entity, trim or something, my constraints, I can start a feature, or I can orient to the sketch plane. I'm sure you can imagine that this is very useful. Okay, but let's go and make a circle here. I'll make it horizontal to the origin. Say that this is 80 millimeters and that this is a 20 millimeter circle. Let's say now that I want to create a hole based on that circle, right? I want to extrude cut that. Normally, what do? You deactivate your sketch and go and select cut extrude, right? Well, no, you hit spacebar, you bring the hurl bar up, and you select extrude cut. And the extrude cut command comes up with your sketch already selected, and you can create your extruded cut, right? Now, here's another tip from Ty, right? And I picked this up watching his qualifier video for the Spring Open, for Too Tall Toby's Spring Open. When an extrude menu pops up, the depth is highlighted, which is very useful because you can just say like -5, okay, and you just created your extruded cut, right? But let's say that you do not want a specific depth. You want to do it through all, right? Or, a mid-plane extrusion or something. You need to go up here to the type and select it. Well, when you have this highlighted, you can just hit Shift and Tab and you can go up there. Okay, so this is really cool. And when you hit the down arrow, you get the through all one. So let's do that again. Okay, so let's delete that extrusion, back into that sketch. I want to make a hole, like a through hole there. So what do? I turn on my hurl bar, extrude cut, Shift, Tab, down arrow, enter. Okay, that's cool. Now that's what you'd call a combo in Mortal Kombat, right? And finally, let's start a new part again. I want to sketch on the ZX plane. Now the Z is pointing down. If I hit reset U, it's pointing up. And let's do this. 200 millimeters, 75 millimeters, and then I'll start spline. Okay, now hurl bar, revolve, select this. Okay. So this is a thing. I suppose it's a thing, right? Let's shell this now. And yeah, let's give it 2 millimeters. And if we go into the colors, either from here or from up here, let's make this 35% opaque. You could say that this is like a glass of some sort, right? A expensive, pretentious glass for Chianti or something, right? But you need to know the volume of this. So how do you do that? So first of all, you save this, and I'll name it Chianti glass because I am pretentious. Okay, and then I'll go and make a new part. I'll go and make a new part. That new part is going to be a simple cylinder. Now, I want to make sure that this new part is definitely larger than my original one, right? It's large enough for my original one to fit inside it. So I'll just say 200 millimeters, and I'll also say like 300 millimeters height. Okay, look what I'm going to do now. I'm going to go into my Boolean commands, and I'm going to do Boolean subtract. And I'm going to use my Chianti glass. Okay, let's bring it in. Okay, now with Booleans, you just constrain the two in position, and then you execute the Boolean command. So how would you constrain these two, the position of these two? Well, first of all, let's, I actually need to select the surface, okay, and this surface, I don't want them coincident, right? In fact, I want this the surface of the cylinder, of the dumb cylinder, I want it to be slightly below the surface there. And in fact, like let's say 15 millimeters below is a reasonable amount, because maybe that's how high up you would fill it up. Okay, let's say that I would fill it up, this glass up to there, and no more. So what volume of fluid would I get? Okay, so you do that, and then you just put one inside the other. Let's see if I can make the two. It's a spline, it doesn't understand that, but maybe if I catch this edge, yeah, now I get a coaxial. Okay, so what happens now? Well, I execute my Boolean subtract, and what has happened is, if I inspect it, so this is the ZX plane, I'll inspect it along the ZX, flip the section. So look what happened. The glass shape cut that cylinder into two actual parts, two different bodies, okay? And actually, the inner body is the volume I'm looking for, right? The fluid volume I was looking for. So what I need to do now is I'll go into my direct editing tools again. I'll go under move face this time, and there's a command called remove model pieces. This is the extra lump, as Alibre calls it, and I'll just remove it. And look what I have now, right? This is the volume of fluid inside that glass, and I can just go to my physical properties, inspect physical properties. I've hotkeyed that, calculate. Guys, this is your volume precisely, right? If you want that in a in ml or cubic centimeters, you just change your units to centimeters. Calculate again. So that's 12,036 milliliters. So that was a huge glass. It wasn't a Chianti glass after all. It was a Chianti bottle or something. Anyway, that's how you get a volume, right? Now here's a cool part with this whole thing. I'll save this same file as Chianti glass volume. Okay, so I save this little thing. Let me open my glass back up. Let's go into the sketch, and let's make everything a bit more normal. So I'll just make this into 100. Let's make this 30. Let's bring this point there, and this point there, and this point there. Okay. And generate to last feature. So, I mean, I've got a completely different glass going now, right? Let me save that. Okay, I'll close it down. And let me open the Chianti glass volume. Okay, I expected this. Right. It has updated correctly, right? It has updated correctly, right? You see what happened, guys? It's just that the offset that I had used in the Boolean now becomes, non-practical, right? So let's make that 5 millimeters or half a centimeter. Check this out. 100 ml. Now that's a wine glass, right? Parametric volume. It would have been correct the first time had I not used a ridiculous, idiotic offset. But this is parametric volume calculation in Alibre, and that's cool. That's a black belt move. So that's it for today, guys. If you like this, subscribe for more videos like this. Hit the like button, and I'll see you in the next one.